So, as Matt said, Lawrence Meekins, work at Legal & General. Be discussing a project today where we've taken data from the mainframe up to a data warehouse in the cloud. Yeah, just a little bit about Legal & General. Founded quite a long time ago. It's one of the world's largest asset management companies. These days it predominantly sells life insurance and pensions. We have over 10 million customers worldwide. More recently, we've spent over £1 billion regenerating parts of Cardiff, mainly around Central Square. If any of you came by train today, you might have seen our new offices next to the BBC. They're called Calon, which is heart in Welsh. So a little bit about the project. Yeah, so the project's familiar story with a lot of older companies. Our data is all held on a sort of central mainframe on-premise. Ours is at IBM North Harbour. And Legal & General wanted to run some analytical workloads on that up in the cloud. So the sort of data flow for our project was taking data from DB2, an old relational database, over Direct Connect through AWS serverless technologies, and then over AWS PrivateLink into Snowflake, which is a very popular data warehouse that's operating as a SaaS for us. So our users take the same journey via some Zscaler proxies. With the beauty of going over Direct Connect and PrivateLink, no data is traversing the public internet. It all travels over AWS's backbone network. So we're doing an extract, load, and transform process. So we're using a product called Qlik to do the extract and load, and a product called DB2 to do the transform step. We're using a Data Vault 2 pattern, which is a very popular pattern for large data warehouses. It moves data through various stages to a presentation layer, which is what the users interact with. It's a pattern that allows you just to do insert only. You don't ever have to do updates or deletes right through the vaults, and that allows for massive parallelism. So as I mentioned, we're using a product called Qlik Replicate. It's a licensed product, and we're using that for our extract and load process. So Qlik Replicate can do full load and CDC. So if you point it at some new source tables, it will load all that data automatically into your target database, in our case Snowflake, and then automatically swap over to change data capture. And it does that in near real time. It's been an extremely reliable product for us. As far as we know, it's never lost a record. It uses an encrypted EFS volume to keep log stream data, no actual personal data, but largely where it is in the DB2 log stream. We have a desired counter 1 on our ECS container, and that basically means, because it's a long-running task, if AWS ever retires the task or it dies for whatever reason, it just spins up again and then uses that log stream to find its position and start back from where it left off. It comes with a nice UI in production. We monitor it via other means, but if you're in dev or a lower non-prod environment, it's really quite a nice way of monitoring progress of the load. So as I mentioned, we use a product called DB2, one of the world's leading data transformation tools to do our data transformation. There's 2 versions of DB2. There's DB2 Cloud, which is the fully functional SaaS version, and there's DB2 Core, which is an open source version. We're using the open source DB2 Core. DB2 comes with an entire ecosystem where people can write and publish packages, and the package that we use predominantly is Automate DV, and that helps us with our data vault pattern. We also use some of their testing packages. I think Great Expectations is one, and there's a host of others, so that, yeah, there's a whole ecosystem once you're in the DB2 world. So we wanted to run DB2 in AWS, obviously. We wanted to be able to schedule the data transformations. And it could run for longer than 15 minutes, a single transformation. If there's a big batch on the mainframe, a lot of data can come across quickly. So that kind of ruled out Lambda. We wanted to be able to group certain data subject areas together and run those in parallel. We wanted no overlapping runs, so if a transformation in a certain data area is already running, we didn't want a second transformation of the same data area kicking off. We wanted it to be easy to monitor and everything to be deployed via Terraform. So for scheduling, I think James touched on it earlier, Event Bridge Scheduler is a great serverless way of scheduling jobs in AWS. We're showing the console view of it here. Obviously, we're deploying everything via Terraform. But if you do go into the console on the Schedule tab, and you can put in a cron string, it's quite nice. It shows you the next 10 target dates, so you can make sure your schedule is all looking good. And then as sort of Tom and Emily and others have touched upon, within the whole Event Bridge ecosystem now, there's a whole ton of direct integrations where you don't have to write code. So we could have gone straight for a sort of another ECS Fargate container and used that directly to transform the data in Snowflake, directly from Event Bridge Scheduler. But that kind of didn't meet some of our requirements. We'd have to sort of implement in code, the stopping of overlapping runs, the parallelism would have been hard. So no real surprises, and seems to be the theme of the day, is we're using AWS step functions. So our new sort of architecture is Event Bridge Scheduler, calling a step function that calls a lightweight ECS Fargate container, running our DB2, and that's then doing the data transformations directly in Snowflake. So on the right there, we see our skeleton step function template for all our data transformations. The first thing it does is does a list executions call. And as people have said earlier, you could have written that in a Lambda and made an AWS API call. But here again, there's a direct integration. So on the left there, you can just see a bit of JSON that you pass in as config. So we're saying we want all the state machines with the same state ID and a status of running. And then basically returned out of there is that list, which we then parse. I'll go into the parsing in a bit more detail later with a demo. But ultimately there, you've done something with no code again. That then goes into a choice state, and basically if there's already one running already, we just skip it and we log some custom metrics because we want to be able to monitor that. And if there isn't one already running for that subject area, we move into a map state. So the map state is quite powerful within a state step function. It basically allows you to pass in an array of objects, and then step functions will kick those off in parallel for free. So kind of the glue that holds this together for us is we're using Event Bridge Scheduler. Remember we saw the sort of schedule tab earlier, but if we now look at the target tab, we're passing in a JSON payload. So that JSON payload has a list or an array of DB2 tasks in it. In this case, we've got 2 tasks. I think it's one for party data and one for contact info. So what that net effect is, you can then see it referenced in the step function in the map state. That will kick 2 parallel ECS tasks off for you for free. And then we also, into each of those respective tasks, we passed a list of DB2 commands. So via config, we can drive a standard data transformation template and have it totally configurable without any code. So the JSON path stuff can get quite tricky quite quickly. So AWS have added this data flow simulator tool. You may not have noticed it, or you may have done. It's just on the developer resources when you're in step functions. I'll aim to give a little bit of a demo now. As you can see, there's a various bunch of states that you can parse data through as you go through a state machine. And yeah, it can be a bit tricky to get some of the selectors right and the combining the input and output. So AWS gives you some standard data, which is just some movies. Obviously, you can put your own data in there. Then you come into the first one, which is the input path. And if you just want to, say, select the movies out of there, you put an input path selector, and then that gets passed on. And then if you want to filter that, something's not quite working correctly there because I erroneously went one layer too deep. So I can then get rid of that. We now see the movies array is there. I come into the parameters, and now that's working. I'm passing the first movie in. If we move on to the task result, you might get quite a lot out of your task. Again, you can use a result selector to filter that down. So here's the input and output. If we add our own result selector, here we're just getting some certain items out of that result body. We can then combine that with a result path. And you'll see at the bottom there, there's a modified payload. And then you can take that modified payload, use an output path just to get that modified payload out, which then comes out of the state output. So there's a whole bunch of things you can do to sort of parse your data as it flows through the states. And I have to say this tool has been invaluable for us where we're dealing with a lot of JSON path stuff. So yeah, hopefully that'll be useful for some others. I think some people showed earlier, you get a nice GUI with step functions that shows you the running state. Obviously in production, we don't use this to monitor, but where it comes in really useful is if you've been alerted to a failure. So you'll see here on the 26th of September, we had a failure in our step function. So you can then go to that failed run and drill into it a little bit more. So here we can see, in this example, we had a map state with 2 parallel ECS tasks, and the first one failed and the second one succeeded. So you can drill into the one that failed, and you can get an exact timestamp out of it, which is really useful then to correlate to your CloudWatch logs, in our case DB2, so we can find out exactly what was going on in DB2 at that point that caused the step function to fail. So I'm pretty sure no one writes their step functions by hand in the Amazon state language. I'm sure like most people like us, you sort of design them in the nice UI, and then you'll see that there's a code tab at the top of the step function console. If you go into that, on the left you'll see the Amazon state language, which you can write by hand, but it is pretty tricky. So I'm pretty sure everyone does what we do, and then just take that Amazon state language and rip it off into your IAC tool of choice, in our case Terraform. So here we've got a common Terraform module on the right that is basically a cut and paste largely of some of the Amazon state language, and we've just removed things like subnets and database names that are environment specific, and then we've just replace those with Terraform variables. So what that means basically is we can deploy that state machine across many environments with many different configurations without any more effort. So that's really quite powerful. Another thing that we did before we adopted a cloud security posture management tool, we wanted to be alerted if any of our containers were having a new vulnerability. So, like many things in the EventBridge ecosystem now, they publish events to the event bus. So what you can do quite easily here is just add a pattern yourself. So we've added an EventBridge pattern to basically say, let me know of any Inspector 2 findings for high or critical findings on our DB2 core ECR container image. And basically what that does then is you can then target something, in our case, SNS. So again, with no code, what we're getting now, if a new vulnerability is found on an ECR enhanced scan, instantly we'll get an email sent to us, and with a little bit of Outlook rules, we also get a Teams notification. So again, really powerful. If you want to get notified of stuff easily within AWS, Event Bus and EventBridge patterns is the way to go. So if any of you are new to this technology, AWS do a couple of really good free courses that gives you nice badges you can add to LinkedIn if you're into that sort of thing. If you just go to Skill Builder, create yourself a builder ID, and the easiest way of finding these courses is just to put the word badge in and do a search. And up comes a whole bunch of courses, and these two will be in there. You get a whole load of online courses, you get an exam at the end, and if you pass, you get the nice pretty badge. So yeah, I recommend those, and I think after today, you could probably pass the events and workflows ones pretty much without having to do much more. So to summarize really, our sort of end-to-end solution, we're using a lightweight ECS Fargate container for our Qlik replicate to do our extract and load. We're using EventBridge scheduler, scheduling a step function that calls another ECS Fargate container, sometimes in parallel. And that's doing the data transformation in Snowflake for us. Obviously, there's a whole bunch of other AWS tech behind the scenes. So what's next for us? So at the moment, we're just ingesting data directly from DB2, but we need to ingest data because this is a group-wide data house we're providing. We're going to be ingesting stuff. So we have other projects already in AWS that publish stuff to event buses. So we can grab those either via EventBridge pipes. There's loads of options to ingest those sort of data. Many of our old systems are replacing files with APIs. So we hope to be calling some APIs to ingest data that way. Unfortunately, there are still files knocking around the place. So we're looking to use AWS File Transfer Family to allow SFTP in. We also have some other use cases where they're already in AWS, so they might be able to put the files directly into S3. And Snowflake offers some really neat ways of processing those files. So if you've got a sort of medium-sized CSV file, you can just refer to it directly from Snowflake as an external table, as if it was in Snowflake already. But if you need very high performance and you've got vast volumes of data, if you convert that data to an iceberg format, you get near native performance out of Snowflake referencing those iceberg tables. So that's a really powerful feature. The other thing that Snowflake offers, it's a really powerful feature, is data sharing. So whilst many of our users will be logging in directly to the warehouse, either in Snowsight, Tableau, or Power BI, or Alteryx, there's other divisions that want to get their hands on the data to combine with some of the data they have. And Snowflake offer this feature called data sharing, which is secure and cross-cloud. So within your sort of legal and general ecosystem, you can share those databases as if they have them in their own accounts with other divisions. So we're going to be using that extensively in the future. In terms of other tools that live around this system, so we use Wiz as our cloud security posture management tool. And if you've ever managed your vulnerability findings from Security Hub, it's definitely a step up on that. Gives you a nice triage process. Constantly monitors, it's got alerting built in, so that's really neat. We use Grafana for our monitoring and alerting. We use ServiceNow in conjunction with SailPoint to do our user provisioning. So we have forms in ServiceNow that users fill in, goes through a bunch of authorization steps, and then SailPoint automatically provisions those users in both Microsoft Entra ID, or Microsoft AD as it was formerly known, and in Snowflake. So that's really powerful. And it also manages if someone leaves, you just remove them from SailPoint and they're gone from everywhere. So that's really it really. That's kind of our end-to-end extract, transform and load data pipeline with the associated technology. And the beauty of all of that is it's all implemented with not a single server that we've had to provision ourselves. So that's it. Thank you.